Hello there. I'd like to talk about biomolecular nucleophilic substitution, SN2, and compare that with SN1 processes. We need a typical substrate, one for which nucleophilic attack is not too hindered. Let's make it chiral too, to see what happens to stereochemistry. How about R2-chloropentane? In SN2 reactions, the leaving group departs as the nucleophile approaches. Electrons flow from the nucleophile through the carbon and onto the chlorine to form chloride in this case. Here the nucleophile is a cyanide anion. This is a one-step reaction. Reaction rates depend on the concentration of the substrate and on the nucleophile. It is a bimolecular process. A rate constant K is introduced into the rate equation so that rates can be quantitated from the concentrations. If the substrate is 100% optically pure, then the product will be formed in 100% enantiomeric excess. For sure, inversion will occur. However, it's necessary to check the RS configuration of the new chiral center, since the priorities of the groups may change. In this case, the relative priorities do not change, so the product is S. We also cannot be sure about the optical rotations. Just because the starting material rotated plane polarized light to the right, the product doesn't have to. It can rotate to the left or right. There are no intermediates in this reaction, so the profile shows only one maximum, the transition state. That corresponds to the nucleophile partially added to one side of the carbon, while the leaving group departs from the other. There you have it. They're the most important things to remember about SN2. Now let's stack it up side by side with SN1. SN1 has two steps. The first is rate limiting, a carbocation intermediate, and the rate is proportional to only the substrate concentration. It is unimolecular. SN2 proceeds in one fast step, where the rate is proportional to the substrate and nucleophile concentrations. It is bimolecular. Stereochemistries in SN2 are inverted without loss of enantiomeric excess. Reaction profiles for SN1 are two humped camels with two transition states and one intermediate. SN2 profiles have only one hump for the single transition state. These are the important things you need to know about nucleophilic substitutions. You can practice using this little book here and learn about less important features which sometimes come up in exams. This video summarizes all the details. Thank you very much for listening. Bye-bye.